Okay, hello everybody. Welcome to what I'm going to call Devlog 0 of the um, SFramework for Craft Studio. So, since this is the first episode of this, I want to kind of go over what SFramework is to start off, and then I'll kind of go over what is happening here on the screen. So, to start off, SFramework is a framework, obviously, for Craft Studio that enables easier development for two-dimensional games. So, Craft Studio, to begin with, is a free game making program. It was advertised initially as a game to make games. So it's supposed to make game development a little more accessible for people that maybe aren't are starting out or whatever. The whole idea is that it's a very basic and easy to use tool to make games. So in Craft Studio, you code in a scripting language called Lua, and that's what SFramework is built on top of. So if you haven't been able to tell already, SFramework is already actually kind of well into development at this point. So and I just now got the idea to kind of follow my progress along in a devlog style video. So that's what I'm doing. So let's kind of go over what you've been seeing so far. So the objective that I had for this stage or this video was to add on to the existing physics functionality that SFramework brings into Craft Studio by adding a triangle collider. So to preface this, SFramework currently, as of the start of this video, has basic 2D physics with a circle and box colliders, and then it also has a sprite renderer using fonts to animate sprites. So the idea is that I wanted to add triangles to this to make making map colliders easier. So to begin, I had previously made the SFramework physics engine pretty one-sided, I guess would be a good word to describe it. So by that I mean it only had boxes and circles in mind. So I'm using the separating axis theorem to do collision detection, and I kind of used a dumbed down version of that. So instead of going vertex by vertex on a oriented bounding box, I actually just used two axes, because that's all I would have needed to check if it was just boxes, right? So what I first had to do was actually scrap that and basically rewrite how my oriented bounding boxes worked to enable triangles. So this way it makes the algorithm a little bit more exhaustive, but it also makes it more versatile. So in order to do this, I wrote out functions that got the vertices of each of my supported collider types. So that's the box and the triangle. And then what I did from there is I first made sure that it worked for boxes, because if it doesn't work for boxes, it's not going to translate well to a triangle, right? So I went and made it work for boxes at first, and in order to do this, I basically what happens is it takes each vertex and it sequentially subtracts vertices to get our axes. So what I then am able to do is check against each of those axes, and that's how we get our collision data. So once I was able to get the boxes working, then I was able to do it with the triangle. And I ran into a slight issue here. You can see I'm making the collider visualizer right now. So the triangle, I ran into some issues that it actually took a while for me to figure out. And it had to do with how my algorithm worked. Was I was kind of assuming that all I would need were the the differences between vertices to get the correct axes. But if you're not quite familiar with how SAT works, I actually needed to get the normal of that triangle's long face for it to actually work correctly. So this took me a while to figure out, because I was like, oh, obviously there's nothing wrong on the axis, right? But I was thinking in the wrong way. So in order to do that, I had to get the dot product of the axis first, which once I figured that out, it was kind of smooth sailing. But you can see here, I'm kind of, this is, I think, the point where I figured that out. So you can see I'm getting some positive movement there on the screen. So the key that I ran into with a lot of this development is that some cases might work, but not all, if I don't test them, right? That's kind of the whole Murphy's Law here. I would make it work on a single axis, and my logic wouldn't work for other ones. So I ended up, I made sure it worked on all axes and all was squared away, and we were good to go. So now the next thing I had to do was, because of how, like I said, how it was previously coded, I have to update some other things to account for this new collider type. So we've got our 3 available there. You can see it. I also tried to make it pretty robust, so it's case insensitive for it, because you have a user typing something in. You want it to be as versatile as possible. So doing a little bit of docking and a little bit of error checking, and yeah, so that concluded all the changes to SFramework. I think it turned out pretty well, and what I'm going to be able to do next is make map colliders. But as with any development tool, obviously we need some documentation, right? So I went, and my documentation was already pretty, I don't know what the word is. It was hard coded to specific links, and I had just realized I could actually use relative paths to link to the correct doc in my markdown files on GitHub. So I went through and did that, and then I added some new documentation that it accounts for these new changes with the triangle collider. Basically, updating the doc to reflect the commented doc within my source files. So you can see I'm adding that here, the get collider type, set collider type, and the related documentation. So I think I'm going to call it here as we finish up with the doc. I think this is a good start. I'm not quite sure if the commentary was very good, but I'm going to try and improve as I go here. So if there's any suggestions you have for me, please feel free to let me know, and I'll do my best to make them better. So yeah, if you enjoyed, feel free to like and subscribe. Dislike if you didn't, I don't mind. And I'll see you guys later. Thank you.